In this example, you're asked to solve a right triangle, which means we're asked to find the lengths of the missing sides and the measures of any missing angles. So we're talking about triangle ABC, where side A, so the convention is that sides are always labeled with lowercase letters. So this is side A, measures 62.3 inches, and side C measures 73.6 inches. So the first thing to do would be to draw yourself a diagram. Angle C is always the right angle. So this will be angle C in my diagram. And then you can label A and B whichever way you want. Then you label the sides opposite of the corresponding angle. So here's angle A, then this would be side A, which we were given that the length of side A is 62.3 inches. And then opposite of angle B will be side B, so we're going to have to solve for side B. And opposite of angle C would be side C, which this is our other bit of given information. This measures 73.6 inches. Okay, and then I realized I'm going to need a calculator at some point, so I just walked over to grab that. So the first thing, we're given two of the three sides. So the first thing I'm going to go for is to find the length of the third side here, side B. And we can find that if it's a right triangle, then we can use the Pythagorean Theorem, which says that the square of the lengths of the two legs, so A and B, is equal to the square of the hypotenuse, which if we're labeling our angles and sides following this convention that I told you where angle C is always the right angle, then side C is always going to be our hypotenuse. Now, we were provided with the length of A, 62.3 inches, and we were provided with the length of C, 73.6 inches. And so now we can solve for the B squared here, which I'm sorry, that the red marker is faint. I won't use that anymore. By subtracting this 62.3 squared, that quantity from both sides. 0.3 squared. So B squared is equal to 73.6 squared minus 62.3 squared. And so B is equal to the square root of that. It's best to do these computations with the calculator all at once so we can limit any round-off error. So I would advise you to input this all at once. So you'll enter the square root function and then a parentheses so you can enter the 73.6 inches squared minus 62.3 squared in the parentheses there. So let me punch that in, 73.6 squared minus 62.3 squared. And we have side B is equal to about 39.2 inches. I'm rounding it to the same decimal place as our given information there. All right, so now we have the length of all three sides. Next thing is to find the measures of angle A and angle B. Angle C is assumed to be 90 degrees. So two more things that we need to find. Let me go for angle A first. I'll just go in alphabetical order. So if we're trying to solve for angle A here, then relative to angle A, side A would be the opposite side. Side C is the hypotenuse. I'm focusing on the given side lengths as opposed to the side length that we just found. For one thing, this has been rounded off a certain amount, and also in case we made some kind of computational error in finding B. This way it doesn't also mess up your value for A if you rely on the given information as opposed to what we found. So if we have the length of the opposite side and the hypotenuse, then you go back to that SOHCAHTOA acronym. So the SOH, opposite and hypotenuse, tells us we want to use the sine function here. And so sine of angle A is equal to the length of the opposite side, so that's the 62.3 inches, over the length of the hypotenuse. The sine function is equal to that ratio. So I'm going to get rid of this. Probably should have kept that B. So down here it said B was, I believe, 39.2. Okay, so sine A is equal to the ratio of the length of the opposite side over length of the hypotenuse. And so in order to solve for this angle here, we need to get the angle out of the sine function. So in other words, I need to get rid of this sine function here so I have the angle A by itself. And the way to do that is to use a function that we haven't talked about in detail yet. But it's the inverse sine function. So the notation is, it's that inverse function notation. It's the sine function, but with a -1, sine to the -1 of sine of A will give us just angle A. It's equal to, so then I need to do inverse sine of this side. Inverse sine of 62.3 divided by 73.6. And so if you punch that into your calculator, and I believe we want to be in degrees here. So that's one thing, is make sure that your calculator is in degree mode, which mine was not. So it's good that I remembered to check. Inverse sine of 62.3 divided by 73.6 is 57.8. So angle A measures approximately 57.8 degrees. Now, to find angle B, we could use another trig function. But what I would do at this point, if I know that this angle is 90 degrees, and now I know that A is 57.8 degrees, then I would just use the sum of the angles in the triangle, which should be 180 degrees, in order to find B. So the 57.8 degrees that we just found here, plus the 90 degrees for angle C, plus the measure of angle B, should total 180 degrees. If I subtract 90 from both sides, that means 57.8 degrees plus angle B should total 90 degrees. Which makes sense. If this C is taking up 90 degrees of the 180, then the sum of A and B must be 90. So that's what I have here. And so angle B is just equal to 90 degrees minus 57.8 degrees. So what does that be? 32.2. 32.2 degrees for angle B.